next presentation, which is given by Thomas Wenker, Janos Borst, and Andreas Nikla. It sounds a bit technically given the title, but I know it's very political, at least with regard to the findings. So the title is Using Text Classification with the Bayesian Correction to Estimating Over-Reporting in the Creditor Reporting System on Climate Adaptation Finance. Janos and Andreas are both researchers at the Institute of Computer Science at the University of Leipzig. You both are experts in computational methods, machine learning, data management methods, neural networks, and large language models. But as far as I'm informed correctly, today Thomas is presenting for the team. Thomas is one of my colleagues at the German Institute for Development Evaluation. Thomas, you are a team leader and a senior evaluator at the Institute, and your current work is focusing on climate change mitigation, development cooperation in fragile states. This is something we are also working together on, but you also focus on patterns of aid allocation, state capacity building, and dynamics of intra-state conflicts. So good to have you here. The floor is yours.
Yeah, thank you very much for the kind introduction. And thank you very much for giving us the opportunity to present our joint work here in this excellent workshop. I'll head right into it. So in 2009, the signatories to the Copenhagen Accord agreed to mobilize $100 billion yearly by 2020 for climate change adaptation and mitigation. However, to date, there has not been an agreed standard on how to report climate finance. Thus, it's very hard to come up with a valid estimate of the current amount of climate finance, especially as estimates vary among reporting agencies. And this lack of data quality makes it extremely difficult to evaluate how far we have come. We cannot really compare commitments between different donors as they use different reporting standards. We cannot really look at the geographical distribution or the sectoral distribution, given the fact that reporting standards differ. Thus, in essence, bad data quality affects our ability for causal inference and in effect of evaluation or the evaluation of climate aid. So this is the topic we are tackling, and we do so with this paper, which has basically two contributions. First of all, we apply a state-of-the-art machine learning approach to estimate the amount of over-reporting of climate change adaptation finance for all aid activities as they are reported in the OECD DAC CRS dataset. The CRS dataset, for those who are not aware of that, is a public dataset where all OECD donors report their aid activities. So a single line is one aid activity. And this is the unit of observation we are looking at. A second contribution of this paper is that we combine different types of evidence and integrate different types of evidence to come up with a credible estimate of the amount of over-reporting. So what we do is, or I'll come to that in a second. So what has been done before? Machine learning in aid allocation research has been rather simplistic to date. So there have been approaches of keyword searches, manual re-evaluation, qualitative reassessment by in-country experts. And what we try to do is to apply machine learning to estimate the amount of overreporting in the whole data set. There has been a recent paper which is quite similar. That's still missing here on this slide, by Tötzke et al. And we are going in a similar direction. So what's the estimate? What are we getting at? Okay, so the main estimate is the climate change adaptation RIO marker. It was introduced in 2009, and basically each reporting agency to the OECD is asked to mark each aid activity with a RIO marker, and it should mark those aid activities that intend to reduce the vulnerability of human or natural systems to the current and expected impacts of climate change, including climate variability, by maintaining or increasing resilience through increased ability to adapt to or absorb climate change stresses, shocks, and variability, and or by helping to reduce exposure to them. So the handbook says, the OECD handbook says, if you have an activity and the climate change adaptation objective is explicitly indicated in the activity documentation and the activity contains specific measures targeting the definition, then you should apply the RIO marker to it. And the RIO marker can basically take 3 values. 2, if climate change adaptation is a principal objective. 1, if climate change adaptation is a significant objective. Or 0, if it's neither of those. Okay, so what we are basically looking at or trying to do is to evaluate the way that different donors apply this RIO marker to their data, given that we know that reporting standards differ a lot. Okay, so what kind of data sets do we have? What kind of data sets do we combine? So first of all, we have a manual re-evaluation of some 5,000 activities by Romain Wijkmans and others from 2017, which I mentioned earlier. So what we have from that data set is manually coded RIO markers for about 5,000 aid activities. Then we have a second data set, a qualitative re-evaluation that was done by CARE International. It's a lot smaller, but the approach is much more in-depth qualitatively. So the CARE data set has been manually coded based on close reading, and the assessment has been done by country experts. And the third data set, so basically the target we are looking at, is the whole OECD DAC CRS data set, which has more than 1 million entries. Okay, so what do we do to come up with the estimate? First, we use the data set by Wijkmans. That was here the first one, the re-evaluation of 5,000 activities. Then we classify the RIO marker based on the train classifier for all projects in the whole data set. That was number 3 right here. And then we look at, or we estimate, we come up with an estimate of the rate of overreporting if CARE had re-evaluated all projects. And I show you in a second how we did that. So the technique we applied was were neural language models and deep learning. I think since this is a very hot topic right now, you are all very well familiar with it. And for in-depth questions, Janos and Andreas are also here today and are happy to answer more in-depth questions on this very approach. What's important is that the classifier has been trained on a very large amount of freely available text and is able to assess representations in the context they are given, which greatly increases the validity of classifications. Thus, we use it for text classifications. What it basically does is splits the input text into subword units, so-called tokens. Then these are translated into numerical representation, and no one really knows. People know how they come about, but it's very hard to interpret how they look like then. But in the end, what comes out is basically a probability distribution over the 3 possible markers. So in this instance, the classifier would assign a probability of 10% being Rio marker 0, you could say, and so on. So what we then do is we take the highest probability predicted by the classifier and assign this Rio marker to an 8 activity in the CRS dataset. So this is how we come about, or this is how we link the dataset by Weigmans to the whole CRS dataset. So how well does this work? So to make this short, basically the classifier is able to classify with an accuracy of 90%. So if we hide some parts of the dataset where we know the real value, so to say, then we can assess the quality of the classifier and can assess that 90% of its classifications are identical to those of Weigmans, even though the classifier doesn't know the classification. Okay, so what's the result? What you can see here on the y-axis is the amount of overreporting. Overreporting is defined that the Rio marker, which is reported in the official dataset by a donor, is larger than the Rio marker assigned by the classifier. So what the classifier does is it reads through the project description in the CRS dataset, assigns a Rio marker, but it doesn't know the real Rio marker that was reported. And we compare these two values for the Rio markers and classify a given 8 activity as overreported if the classifier comes up with a smaller Rio marker than the one that is reported. Okay, so you can focus on the blue line, which is the overall value across donors, and we come up with an estimate over time that is quite stable, although somewhat improving in the timeline or over time, of around 80%. Okay, so that's maybe a little bit high. So from there, we looked at more qualitative data. And we can look at the projects that have been evaluated in depth by the guys from CARE, who are really looking into these projects. And we can compare for this very small sample how our classifier would estimate the amount of overreporting and how CARE would estimate in this sample overreporting. And for this very sample that has been evaluated by CARE, the classifier would say 54% are overreported, and CARE, which are arguably a bit more valid since they have put much more work or much more evidence in estimating overreporting, finds only 21% of overreporting. So we have a small n data set with a high quality by CARE, which tells us it's about 21% or 22%. And we have our classifier with this really large n, but with a presumably lower quality, at least with much less information, only the project description, which comes up with 54% of overreporting. So we have a quite large difference. Okay, so what can we do about that? What we can do is we can try, or we can use Bayes' theorem to estimate how CARE would have evaluated the whole data set if it had seen the whole data set. So we have the marginal probability of the classifier. So basically the classifier result of overreporting on the right-hand side. And we have on the left-hand side the marginal probability of CARE identifying overreporting if it had seen the whole data set. And this formula comes about by simply rearranging Bayes' theorem, and this factor here in between is the correction factor to somehow downgrade the estimate of our classifier to a arguably more realistic estimate of what CARE would have said. And this correction factor comes about from comparing the classifications in that small sample of the data set where we know both the value of our classifier and the value of the CARE data set. So what happens if we apply the correction factor? So what you can see here is basically the very same as you saw before as a blue line, but just the arrangement is different. So on the y-axis now we have the years, on the x-axis we have the over-reporting rate. These are the classifier results. You can ignore the two different types of dots. Then we apply the correction factor, and because we know that we are somehow missing information, we know that from the CARE data set, and can update our classifier result to a new, more conservative estimate that basically assesses how a qualitative researcher, you could say, had evaluated the whole CRS data set with regard to the amount of over-reporting. And since the sample is not too big and we don't have too much information from the qualitative data set, there's some uncertainty in this estimate, but we can say round about a third of all activities are probably over-reported. Okay, so here comes the conclusion. First of all, the re-evaluation of the RIO markers indicates a lack of quality in self-reporting of donors. So we find that a significant share of those activities reported as climate change adaptation in the OECD DAC dataset don't really mention climate change adaptation in their descriptions. And even if we account for the fact that we don't have that much information, namely only the short descriptions in the CRS dataset, even if we account for that by integrating qualitative, more high quality evidence, we can say that about every third activity with a given level of uncertainty is categorized by donors as adaptation aid, although it is probably not adaptation related. We don't find big changes in reporting practices over time. And in the future, we are looking into integrating our findings with what others have found and to investigate more closely country-specific results. Thank you for your kind attention.
Thank you very much, Thomas and team, Janos and Andreas. I have the impression that this is a very interesting, impressive example how the digitalization of evaluation helps to provide investigative findings, so to say. So you could also call it a Mogadishu result, which might hit like a bomb in the political area. So for me, it would be interesting what kind of reaction you expect from the political area, or did you already receive a reaction?
At this stage, we have not really received any reaction since we are currently, or we just have finished the paper, which is a bit technical, so to say, which details the methodological approach or the methods. But yeah, we are currently integrating this into an evaluation on climate change mitigation and extending this classification process also to climate change mitigation projects. And once we are finished with that, we are quite far, then we can assess the quality of reporting for all of climate finance.
Thanks, Thomas. So I would also like to invite the attendees to post questions and comments in the chat. We have 9 more minutes. And here's also one first question from Mirai. I hope to pronounce it right. Mirai Rana. Very interesting approach. I'm wondering if the other alternative approach of running the classifier on the same sample that CARE worked was to compare the results and tweak the classifier results. Maybe you can say something on this. More questions and comments are welcome. Onirai, maybe you want to.
Sorry, yeah, if you could, maybe you could clarify the question. So whether.
Maybe I try to.
Yeah. So thanks, Andreas.
Yeah, try to interpret it as maybe the question is why don't we just use the CARE data set as training data? Is that right? Can you confirm?
Yeah, roughly that's what I was.
Yeah. So yeah, basically the problem in using the CARE data set is that the text, the kind of text that we find in the CARE data set is much more or has much more value than the text in a normal CRS data set. So we tried to annotate the CRS data set with additional data from the IATI data, which actually was done by the CARE evaluation. But this is still not possible because you cannot connect both data sets because there are no agreed standards on identifiers to process them together. So we tried some text similarity tasks and so on, but it wasn't very reliable. And if you look closely at the CARE data set, then you have much more text included in this data set. And also they pretty much selected only interesting examples to evaluate, which means that you don't have the same distribution of training data as be expected in the CRS data, which means that the classifier you would train on that would have more information, but at least you only have, I guess, they chose a lot of Rio Marker 2 examples, and I think Rio Marker 1 is missing from that example from the CARE data set. I don't know if you can confirm, Thomas, but this was basically a major difference between both data sets. So we decided not directly to train on it or to use it as a training data set because it's not reliable then on the target classification that we want to do. Janos, maybe you can say something also.
Yeah, I think one of the main reasons that we also didn't use it was just the quantity of data. It's 100 samples, and if you want to train a classifier on that few samples and really evaluate how well it works, then it's just too small amount. It's too small, the data set, and that's why we tried this approach by training on the large scale data set and then correcting with the smaller scale data set.
Thanks a lot. So we have 5 more minutes and 3 more questions. One question is from Kai. Kai is asking, instead of correction, correction the estimates after the training, what else could help in your opinion to improve your estimates? For example, better language models, more text information from the projects. This is one question. The other question is coming from Thürer. Would you rather see a problem in some kind of sloppy reporting where relevant keywords were missed to be written in? Or would you rather argue that there is an actual mismatch of funds being channeled to projects which have another focus but CCA? Maybe we leave it with these 2 questions first.
Maybe I can very quickly. I find this Bayesian integration of different types of evidence very promising. With regard to the technical approach, I would hand over to my colleagues from Leipzig because they know much more about that. And with regard to the second question of sloppy reporting, I would say, well, markers, you don't have really to decide on whether putting a marker on a project or not. So it's basically, it doesn't cost you anything because you don't have to, you're not restricted in any sense. Like with a sector, you have to choose one single sector and you cannot choose the others. But markers are like stickers and you can put them on 8 activities. So there's yeah, it's really easy to put markers on different 8 activities. And from everything we know, from all studies that have looked at this issue, we can assume that there is a certain amount of overreporting. And what we try to do is to come up with the best available evidence, synthesize that for the whole data set, and come up with the best available estimate for that. And sorry, with regard to the technical questions, or maybe improvements, Janos? Thanks.
Yeah,
maybe a short answer, Janos, and then we can have 2 more questions. That is okay with you.
Yeah, I'll try to make it short. So basically, there are 2 ways to think about thinking about better estimates. So the first one would be better classifiers, and of course, the way to a better classifier is always better data and more data, because the project descriptions are very brief. Better language models and stuff, yeah, the improvement in the computational science sense would also be helpful, but I think at the moment it's mainly about more data and better quality data. And the second thing is a better estimate in the sense of the Bayesian correction factor. The interval of our estimation is pretty large, because the care data set with which we estimated is pretty small. So if we get more high quality care annotated data, we can narrow down the estimation interval. This would be 2 ways, I think, to improve on the estimation.
Many thanks, Janos. 2 more questions, and short answers are welcome as well. And maybe later on you can also get in touch with the people who ask questions. One question is, in your study, you rely very much on the findings of care. This is from Dirk. Are you not afraid that results might be refuted politically, as care is an NGO with its own political lobby agenda towards climate politics? So a political question. And one more from Robert Uden, very interesting. What evaluation is that you are looking at for climate mitigation? We evaluated the Swedish program for international climate change mitigation at Kyoto, but the data reliability was poor. Yes.
So with regard to the first question on the political refutation, what we do is integrate available evidence and integrate different types of available evidence. So I think it's extremely important to assess the rigor that has been gone into evaluating these different projects. However, I think the answer is probably what Janos also said. It's probably the more data we have and the more estimates we have, the harder it will be for political implementers to refute our results, because what we come up with is an estimate with a given uncertainty range. And I think you could argue that it might be a bit higher in this range, a bit lower in this range, but given all the available evidence, I think we are not too far off from a credible estimate. So I think this would be the answer. What evaluation that you are looking at for climate change mitigation? Actually, what we do is we apply we re-evaluate it by ourselves, some of the programs, but we still have to do the qualitative re-evaluation. So that has not happened yet. What we will do is use project documentation from the German Development Corporation at first, and there are some very specific tools for measuring the contribution to climate change mitigation on the project level perspective that is, in my eyes, valid to come up with a credible qualitative estimate. So project documentation is the answer.
Perfect. Thank you very much, Thomas, Andreas, and Janos, for this interesting insights.